Right, here's a frameworks question from Mei M2 January 2011. Question number 3. Take a moment to read the question. This is the first part of the question, the description. So pause the video and read that, and then carry on. This is the second part coming up, and that's all the actual questions. So when you're ready, resume playing the video and let's carry on. Right, for the first part, in the wording, a couple of slides back, it's described the external forces which are shown in blue. And this, as in all framework questions, you need two diagrams. This is the first diagram showing external forces and then all the dimensions. I haven't shown the angles because they're all 60 or 30, the equilateral triangles. So resolving horizontally for the whole framework. Resolving horizontally, then x must equal to 50. That's that one done. Resolving vertically, this is what part 1 asks us to do for 2 marks. Resolving vertically, y must equal, y plus 45 must equal r, or y equals r minus 45. That's that. Now that's not enough to find y and r, so we need one more equation. Take a moment to out the point A so that we don't bring in x or y. Taking a moment to add A, the sides are all of length 2, so that's nice. R times 1 will be balanced by the 50 goes through A, so just equal to 45 times 3. So R equals 135, which they've asked us to show. So that's correct. And y is 90, because y is r 135 minus 45, which is 90. So, all of that done. We don't need any more room on this page, we've got room to spare. To save going back, let's do this in sections. There are 2 marks for that. Well, there's 2 marks for resolving there. Actually B marks they were, not that it matters. B marks for seeing those resolving equations, and then an M1 and 2 marks for getting M1 for taking moments and 2 marks for getting the required values. That's the total of 5 marks for parts 1 and 2. Part 3 says show the forces internal to the rods. So the usual thing now, we've got to find all the tensions and compressions in the rods, and we'll answer parts 3 and 4 but not part 5 on this page. So we've got to go around now and put forces on the rods, internal forces. It doesn't matter if you get the direction wrong, but it's best if you can get them right to avoid too many minus signs. So if we start at C, let me just label the points. C is down here, and that's B there, and that's A at the top, and that's D here. At C, well, we know that the force here must be that way because of the 45 downwards, so that means it's in tension, pulling in at both sides, and I'll call that U. It doesn't matter what, I just call them capital letters. That's U. Now because U has a component to the left at C, there must be a thrust in this rod. Let's call that one T. Don't know why I've called it T, but I can't change it now because I've worked through with these letters. Then we'll go up to D, and there must be a force like that upwards here to counterbalance the U down. Let's call that S. That's a thrust force, so that's down here like that. And going on like that, there must be a force here. That's a tension, let's call it Q. And one more, P, like that. So I've called the forces P, Q, S, T, U. Right. Let's start at C. It's a good idea to show like that the points you're considering, and we're looking at the equilibrium of the actual pins that are holding this framework together. So at C, resolving vertically, U cos 30 equals 45 degrees. Equals 45, sorry. U cos 30 equals 45. So U equals 45 over cos 30, that's 90 over root 3, or 30 root 3. Pause and take a moment to check that if you want to. Horizontally, U cos 60 equals T. So T equals 15 root 3. Good. Now let's go to, which point should we go to next? Let's go to D next. Point D. And at D, S cos 60 equals U cos 60. Wait a minute, something's wrong here. Oh no, vertically, yes, that makes sense. Resolving vertically at the point D, S cos 60 equals U cos 60. So S equals U, in other words. And also, let's fill it in. S equals U then, which is 30 root 3. Right? At A, just moving to using up some space here so I don't have to go on to the next page. At the point A, you might like to pause the video and see if you can form an equation at A. Well, I'm going to go with P cos 30 equals 90. P cos 30 is 90, so that's P equals 60 root 3. What's wrong with my pen? B equals 60 root 3. Okay, that's P, S, U, and T. Is that everything? No, we've just got to find Q now. Still at A, P cos 60. P cos 60 plus 50. Apologies, I'm having trouble with my graphics tablet. P cos 60 plus 50 equals Q. Yep. And that gives us Q is equal to 30 root 3 plus 50. 30 root 3, oh come on. I think I've got a dead patch on my graphics tablet. 30 root 3 plus 50. So take a moment and check that. Check those amounts. I've got to indicate whether they're tension or compression all the way through this. So I'm going to get blue and go through these and just indicate whether they're tension or compression. So U is a tension. If you look at it, that's a tension. T is T will be a compression. Just look at the way the force is going. S is a compression and P is a compression. And then Q is a tension. In the case of the T's and C's indicate tension or compression. And ideally you should show, instead of calling them U and P and Q and S, you should list them all underneath that, so it's easy for the examiner to see which. So in other words, say instead of U, say BD is 30 root 3. I won't add more to this slide because it's already quite cluttered, but it would be good to do that just to make marking a bit easier. Right, that's nearly it. There's just part 5 now, which I'll go into the next slide for. It says, suppose the force of magnitude 50 applied at D, in other words here, is no longer horizontal, and the system remains in equilibrium in the same position. So if that force was still 50 but not horizontal, show that the forces in rods, by considering the, that's important, by considering the equilibrium at C, show the forces in rods CD and BC are unchanged. In other words, these forces. Well, actually, it's only 2 marks and it's very straightforward. If we go on to the next page, I think I've drawn the diagram. Yeah, that was the point C, and all we've got to do for that is say, if I call this, what did I call that? Sorry to go back. I called that force U and the other one T. So that was U and that one was T. But if I resolve vertically at C, U cos 30, or U sine 60 if you prefer, is equal to 45. And resolving horizontally at C, the point is that the equations haven't changed. U cos 60 equals T. So all you need to say is these equations are unchanged because they relate to the equilibrium of the point C. In other words, the pin holding the framework together at the point C. So it's unchanged by force at D. And that's it, for 2 marks for that. Okay, I hope that was useful. That was Mei Jan 2011 question 3, frameworks.